Hi everyone, welcome to Group 5's caststock design presentation. On the left is a hand drawing of the site plan where the collapsed wall occurred, which happened near the caststock railway bridge. On the right is a detailed close-up of the failed area, where the failed wall is highlighted in red. The access point, which is shown in arrow, links Lower Kelly to the construction site, so it'll be easier for trucks to transport construction materials to the storage room. There will also be a tent and toilet room for the workers as well as the tent for storing equipment. This drawing shows a cross-section of the wall before the failure. The outline of the collapsed wall is shown in red dotted lines on the cross-section drawing, as well as the water that gathered, forming a small puddle. The main issue we realized was that there was a large buildup of water in the soil which caused the wall to collapse. One of the possibilities of this was due to vegetation blocking the weep holes, which prevented water from leaving the soil. We deduced this from calculating the overturning moment of the soil and water together, which was 59.8 kilonewtons meter, the resisting moment of the wall, which was 32.2 kilonewtons meter, which resulted in a factor of safety of 0.54. Therefore, the wall would have collapsed with the soil and the water together. After finding out the reason why the old wall failed and doing research about the newly constructed concrete gravity wall, we decided our wall must be easy to construct and importantly much safer. So we decided to construct using secure ground blocks from a UK company called Tobermoor. The blocks will be locked in place using gravel and geogrid, and the total construction will be completely concrete free, making it more environmentally friendly. Also, the geogrid reinforcement would allow the soil behind the wall to act as one singular mass by greatly increasing the frictional coefficient of the soil, providing added safety. Finally, to preserve the look of the area, we will construct a 1 meter fence on top of our wall out of salvaged old material, allowing the wall to have a continuous look. We did some calculations to check if our design would be able to hold back the soil. We found that the force from the soil is roughly 27 kilonewtons, which creates an overturning moment of 32 kilonewtons meter. Then we calculated that the weight of our retaining wall, consisting of the layer of blocks as well as the gravel behind it, which is held together by geogrid, the total weight came out as 43.5 kilonewtons. The 87 kilonewtons. Giving a resisting moment of 43.5 kilonewtons meter. Using these moments, we calculated the factor of safety in overturning to be 1.34. We also calculated the factor of safety in sliding by using the coefficient of friction for brick masonry on gravel, which is 0.6, which gave us 1.58. To both cases, we can see that our design will not fail. First, construction workers will bridge off the collapsed area with fences so that people don't walk near the collapsed area for their safety. Then they will check the walls next to the collapsed area to see if they are damaged and needs to be repaired as well. After surveying the wall, the whole area will need to be demolished, has to be bridged off. For a retaining wall, we decided to repair 10 meters from each side of the failed area. Also, areas will be designated for the toilets and setting up tents for the storage equipment and materials and workers to rest in. After, the workers will construct a safe pathway for pedestrians to get past the area that is under construction. For step 4, the digger with a replaceable jackhammer will be brought on site. We decided on the digger because it is small and it'll be able to fit through the narrow road behind the failed retaining wall to get down to the construction area. It will be used to break off excess part of the damaged wall. The workers will clear the rubble using shovels and wheelbarrows and store the material so that it can be reused. Meanwhile, the geogrid will be transported to the area and workers will unload it from the truck. The workers will place the geogrid on the 3 sides of the excavated area by rolling it out from the top of the road down to the bottom of the excavation. The geogrid is used to hold loose soil back so it doesn't fall into the excavated area and block the draining. Then the surface of the excavated area will be flattened with a compactor. Next, all the materials like gravel and blocks are transported on-site by a crane truck, which will lower the materials from the road down to the construction site. The workers will then carry the materials to the storage area. Then, using a string, mark out the boundaries for the foundation and start digging the foundations, which are 300 millimeters deep and 600 millimeters wide. Once the foundations are dug out, pour the gravel into the foundation and compact it using a compactor. On the top of the compacted gravel, the worker will start placing the first layer of blocks and fill them up with gravel to increase the wall's weight. The drainage pipe will be placed behind the first layer of blocks. The pipe is placed there because the gravel is permeable. All the water will go down to the drainage pipe and it won't collect behind the wall. Next, we will fill the front base of wall with on-site material and brush the top of the blocks to ensure the next layer is level, after which we will be placing another layer of bricks and filling the void with gravel. Now that the first layer from ground level has been placed, we will backfill the area behind the wall. The first 350 millimeters will be filled with gravel and the rest with on-site material. We will use the compactor to compact every 250 millimeter layer of material that gets placed. Making sure that the compactor stays 1 meter away from the wall and working away from it. Now we will roll out the geogrid on the layer, making sure the geogrid does not overlap one another so that as that can induce rotting. Now that the layer is successfully constructed, we will be repeating steps of placing, filling, compacting, and rolling, where the geogrid will be rolled every 3 layers of blocks. To ensure that the workers are able to reach the half-constructed wall safely, we will be constructing scaffolding when the wall reaches 1 meter. When the wall reaches road level, we will place top caps for the wall and constructing the road, after which the fence wall on top will be constructed using salvaged material and the pathway will be removed. Also, the gaps between the old wall and the new wall will be filled with mortar, which is what was used in the construction of the old wall. As seen in the connection diagram, after the construction of the wall will be fully functional with the road on the top. Also, the look of the area will not be damaged and kept using the original salvage material of the fence. We believe our wall is better than the old wall. This is because the wall is safer, more environmentally friendly.